Welcome everyone. In this video, I'll explore an essential term in the context of GPUs, the compute capability. The compute capability, or the CC number, or even the compute capability version number of any GPU or any architecture refers to a design classification used by NVIDIA. It indicates the general features and processing power of NVIDIA's GPUs. To understand this more, let's start with this question. How is the compute capability numbered or given a version number? The compute capability is expressed as a version number, such as 3.0, 5.1, or 7.5. Each version corresponds to a specific generation of GPUs and the capabilities they support. The first number that is positioned before the dot typically indicates a major architectural change, while the second number that is positioned after the dot represents a minor improvements or extensions. Let's take an example to illustrate this more. The compute capability of the Volta architecture is labeled as 7. This numerical designation reflects the specific set of features, the capabilities, the improvements presented in this architecture which were cutting edge at the time of its release. Volta was notable for its introduction of the Tensor Cores units, which significantly boosted the performance in certain types of computations, particularly in the artificial intelligence and deep learning applications. Moving to the Ampere architecture, its compute capability version or number is 8.0. This increment indicates substantial enhancements in both hardware and software compared to the Volta architecture. The Ampere architecture has various improvements, including more efficient and powerful tensor cores, larger memory bandwidth, and better energy efficiency, among other advancements. These enhancements not only boosted the performance, but also improved the efficiency and versatility of the GPUs for a broader range of applications. The same concept about the CC or the compute capability applies to all other architectures. Now let's discuss the second point in this video, the feature support. Different versions of compute capability enable different features. This can include the types of mathematical operations that the GPU can perform, the level of parallelism it can handle, the memory access capabilities, and more other features. For example, when navigating to the link of the CUDA programming documentation, you would find many sections about the CUDA GPU programming. One of these sections is dedicated to the GPU compute capability. This section comprehensively covers everything necessary to grasp this concept. For our discussion, I'll concentrate on a particular table within this section because it contains the essential information we need. In Table 17, you can find a structured layout where different compute capability versions are listed across the columns, and the corresponding features are shown in the rows. This table serves as a comparison chart, allowing developers to quickly see which features are available on the GPUs based on their compute capability. Let's take the compute capability 5.0 as example. A vertical scan for all rows from up to down would reveal a mixture of available and unavailable features for this particular version. For example, GPUs with this compute capability do not support the half-precision operations, as indicated here in this part. You can see that this feature is not included with the compute capability 5. The tensor cores, which are another significant units, are only present from compute capability 7 and above. This is clearly indicated in the table with a no for columns representing the compute capability versions less than 7, and yes in the compute capability for versions from 7 and above. The same concept can be found in Table 18, but I'll leave it to you to explore and review on your own. Now let's go to the third point of this video, the software compatibility. The compute capability of a GPU determines which version of the CUDA programming toolkit it can run. Higher compute capability versions support newer versions of the CUDA toolkit, which in turn support more advanced computing features and better performance optimizations. To illustrate the concept of software compatibility, let's take the example of the PTX compatibility. And we can consider the PTX as an assembly language just for the purpose of simplicity. Certain PTX instructions are reliant on the compute capability version of the device. In other words, some PTX instructions can only be executed on a device with a specific compute capability version. This restriction arises because these instructions depend on a specific hardware units or features that are exclusive to a certain GPUs with particular compute capabilities. By following the provided link to the CUDA C programming guide, one would find a clear documentation stating that some PTX instructions have requirements in terms of the compute capability. For instance, the word shuffle functions, which are instrumental in enabling threads within a warp to share data without involving shared or global memory. These operations or functions are only available on devices with a compute capability higher than 5. If this is not clear, let's dive into another example. Let's say that you are working on a project that requires the latest in machine learning, or let's say that you are developing a complex simulation. Then the compute capability of your GPU will determine if you can use the latest CUDA toolkit, which is packed with the newest features and optimizations for the performance which you might need for your application. For example, if you are using the Hopper architecture GPU, one of the most recent GPUs in the world, then you are looking at a compute capability of 9.x as shown in this table. This is not just an incremental step up from the previous generations. It represents the compatibility with the latest CUDA toolkit versions, starting from 11.8 and above. This means that your Hopper GPU is ready to handle the most advanced computational tasks you give to it. Furthermore, it is advisable to avoid using older CUDA versions lower than the minimum value here. For example, in the Hopper architecture, you cannot use a CUDA version lower than 11.8. Otherwise, you will get an error message indicating an incompatible CUDA version. Let's take another example, the Maxwell architecture or the Maxwell GPUs. From this table, you can see that the compute capability number of this architecture is 5.x. Then you cannot use a CUDA toolkit that is lower than 6.5. This is what do we mean by software compatibility in terms of the compute capability number. So the relationship between the compute capability and the supported CUDA versions, as mentioned in this table, is central to understanding how to align your hardware choices with your software needs. It is not just about having a powerful GPU. It is about having a GPU that is compatible with the tools you need to use. So whether you are a developer, a researcher, or someone who relies on a GPUs for intensive tasks, knowing this relationship helps ensure that your projects run smoothly, efficiently, and without any unwelcome surprises. Finally, on the shown web page here, you can discover various GPUs designed for distinct applications, as shown here and here, each one accompanied by its corresponding compute capability as detailed in these tables.